You're on
You need
mute.
to take yourself off mute, Dion.
Will help. Thanks again. You know, Andy, you always help me out. There's always things I forget. Comes with age. Well, welcome everybody to another webinar in our Edge to Enterprise webinar series. And I can't remember which number this is, Andy.
I think it's 8.
8? Oh, goodness. Time flies. Okay, with me today is, of course, Andy Graham, which you would have seen during the series if you've joined us. Hello, Andy.
Hi, Dion.
And you are Solutions Manager at Solutions PT. And
that's right.
Nice to have you once again with us. I love your background, by the way.
You recognize it?
I recognize it. It's from one of our good customers in the Middle East. And then we've got Tim Harrison, which you would have also met in one of our webinars, System Architect at Solutions PT. Hello, Tim.
Hi, Dion. Hi, Andy.
Hi, Tim.
Okay, so today, yes, we're talking about IIoT. But just before we start talking about that, ooh, next one, Andy. There we go. We just want to remind those of you that has not got the news yet, that we're busy with the transition of branding from Wonderware to AVEVA. So we're busy changing our branding. You, of course, will know that AVEVA acquired the Wonderware brand, but a whole lot of other brands as well, and we're amalgamating them all into AVEVA branding, but it's, of course, the same good old Wonderware that you've got to know over the last 30-odd years. Okay. The other thing that we're going to do today is a new thing we're going to try, because in the past we've had a lot of people that want to get more information, so we thought let's make it a quick way for you to get more information from us. So in the chat right now, I'm going to quickly pop in a link to all of you. And so if you want a demonstration, personal demonstration of what we did today, or any other one, you can just follow that link and it will help you to register or to do your own personal demo. Okay, so what are we talking about today? We're talking about IIoT, but I think we're not going to bore you with the why of IIoT and what is IIoT. I think most of you are probably bored of hearing about IIoT. There's such a lot of hype around it, and really what we want to do today is to get to the reality of it. And at the end of the day, we really want you to go away with three takeaways, which we really believe in. It's one, that IoT can make a positive change to your company. It is there to help you. We're not doing IoT for IoT's sake. We're doing it to help our customers make a real difference, make a real change in their companies, help their companies. The second thing is that it is not scary. It is, and that's what we're going to try and do today, is to show you how simple it is, how quickly you can start, and you don't have to invest a whole lot of time and money to do that. It is really quick to get going, and you can incrementally then see what kind of value you can get out of the system. And then, of course, we're here to help you. So along this journey, we here, Solutions PT, that is what we do. We help people to help get the benefit out of the software that we provide. So let's get started, Andy.
Thanks, Dion. And it's also worth mentioning as well, if you've got any questions as we go through this, there's a Q&A box on your Zoom session. So just pop those in there and we'll find some time at the end to answer those questions for you. So yeah, we've obviously run through some themes throughout this entire webinar series, and it's all about connecting, empowering and transforming our workforce and our organizations, the enterprises, the people that we help, that Dean was talking about, across all of these verticals. And we've been doing that for a long time. And our portfolio worldwide has #1 market share and is sold over 2 million licenses. So, you know, it's been around a long time. It's a fantastic brand, and it's still the same brand you know and love, or the same software, certainly. If we move into our edge to enterprise architecture, and it's this very simple approach in terms of our asset location, defined here in 3 areas: our asset location, our control room or unified operations center, and all the way up to that enterprise. And down at that asset location level, we've obviously got our device and the softwares that sit in that area to control, to get those products out the door at that bottom level. That's what's making our money. We may move up into our control room or operations center with something like system platform. This type of product might sit here to have a complete overarching view of the entire facility, or even further afield and all the way up to the enterprise. And the IoT stuff we're going to talk about today will really start to highlight how that's a possibility with something like system platform too. And then all the way up to the enterprise, where we're talking about either our development environment through Integration Studio or Insight, which is our cloud-based analytics, and much more than that platform now. But you still have to run hardware on, sorry, you still have to run these software packages on hardware at that local level. So again, we deploy the right hardware for your needs, depending on things like IP rating or fault tolerance requirement, things like that. And we do that through our partners of Advanced and Stratus that we've worked with for many, many years. But I think we should probably get into it in a bit more detail. So if we have a look a little bit closer at the asset itself, and you've probably had something on your facility that has been delivered perhaps by an OEM that already has the data in it that you require to do what you need to do, but you just perhaps not collating it in the right way, not storing it simply out to our platforms or out to a centralized cloud historian. Cloud seems like the obvious route to go when you're looking at getting this data outside. You may be storing all that data locally, but you might not be doing quite the right things with it. But there are still instances. Sorry, Jim, you're going to.
Yeah. I was going to say that we also hear from a lot of our customers that, you know, because a lot of people talk about, oh, you've got to put in an MES system, and when you look at the large deployment and cost in all of that, it might be prohibitive. So you know the data is locked up in those machines, and how do you get better value out of all of that data?
Yeah, and you raise a really good point, because often people can see, well, I need to deploy an MES solution because I know that it'll give me the return on investment, or I'm pretty sure it will, but it's very hard to justify that big capital expenditure. So there's now lots of different ways that you can I guess dip your toe in the water, or you know, you can get quick wins, especially when you're deploying things like these IoT devices. And if you're under an area where you don't quite have the values that you need out of it, you might want to deploy additional sensors to get that meaningful information. So if we're not already storing it, perhaps we need some temperature data coming from our solution. And we may do that in the traditional manner. We might wire it into the existing looms that we have there. But again, it can be quite an intrusive, quite a costly process to do this. We know we need this data because we know we want to do more with it, but we perhaps want to do it in a non-intrusive fashion. So we do that with the likes of something like an IoT device. That allows us to not alter the process, to not alter things in the PLC, and to attach these sensors without that. So if we look at something like temperature, you might want to look at something like vibration. We could then start to look at something like analytics, and we've talked about this previously a little bit, but understanding things like what-if scenarios, understanding if something's going to fail in the future, so that we can prevent that and, you know, reduce our downtime. If, for example, our equipment has got things like product counts coming off the end, the good and bad products, perhaps whether the machine's been down or not, the minute we can start to store that data, we can start to get things like OEE information in there. And there's some really, really simple ways to do that. And I'll just take you through a screen very quickly in our cloud platform. So if you do have those details and that data from that asset, as soon as you get it into this cloud platform, it's almost out of the box. I say almost. There's some very small configuration to do, but so long as you tell it what the downtime item is coming from your asset, where perhaps the downtime reason codes are coming from, then it will automatically build these for you. and you can start to really get a handle on it.
So I suppose this is the benefit that the cloud brings. We know we've got this data, and we know what we can achieve with the data. And the cloud really makes it easy and quick to get to there, because you don't have to install machines on your site to have an MES application. It's built already in the cloud, and out of the box, you get what you're seeing in front of you.
Yeah, and all we need is a few items from our asset to be able to deploy this and build this. It's really very simple. Right.
So okay. So this sounds good, but what's the reality? How do we actually get stuff from our on-site to this cloud platform?
I'm glad you asked, Dion, because if we just take this out into here we've got our cloud platform at the top, we've got our asset location at the bottom level. So this is where they live. These are the AVEVA products that we've got at the bottom, and in between we will have some form of IT infrastructure. And we're mentioning a lot about cloud because of the ease of getting that data out there that Dion just referred to. The real benefit and the obvious quick wins you can get from having data sent to that cloud. But the key question there, Dion, was how do we do that? So from an IT perspective, there's obviously things like security concerns that we're all concerned about these days. So more often than not, you will have a demilitarized zone across your network in some way, shape or form, and to have the right security best practices, you will have different layers in your network infrastructure, and you'll want to secure that outbound connection through that demilitarized zone. So what we do from our AVEVA products is secure that through something called a DMZ secure link, that will get that data out to the cloud. And it's something that is managed by the AVEVA, so it's digitally signed to prevent things like tampering with it and things like that. But it's that outbound connection, and it's built in. So this is something that Tim's going to show us a demo of from our AVEVA Edge solution, getting data out to and how you configure that in the solution to get it to the cloud platform itself.
Okay, so Tim, are you going to show us quickly how do you actually, now we're collecting data at the edge?
Thanks. Yeah, absolutely. I mean, hopefully I'm sharing my screen here.
Yeah.
Some of the viewers may already be familiar with the AVEVA Edge front end because of the webinar we did earlier. But I'll just take you through it. So, clearly we've got some field I/O that we need to connect to. So in my case, I've got a Modbus simulator here just to kind of have it in the background. And I'm going to use Edge. I actually already am using Edge to connect to this, and I'll just take you through that. So in Edge, it's got quite a full list of drivers that you can add. I've already added the Modbus TCP driver down here. And I have
over 200, if I can remember right, over 200 drivers.
Seems to ring a bell, but yes, well over 200, well over 200. And the purpose of this driver sheet is really just to allow you to very quickly create some tags in your project, or link tags that are already existing in your database, and link them to the Modbus registers that you see here. So I'm basically using the input registers 1, 2, and 3 at the moment, which are kind of running up here, and I've got just two dials here that are changing. But it's as simple as that, Dion, to bring that data in. The next question is, okay, so we want to push this out to the cloud historian. This is just one of the products that has a publisher that allows users to very quickly do this. I'll take you through that. So in Edge, there is a trend facility. Edge is good at either logging data to the proprietary database, to a SQL database, to the on-premise historian, or alternatively, the cloud historian. So I created a sheet. It's as easy as just right-clicking insert, and you can actually add a sheet very easily into Edge. Just giving it a description, just to remind me that this sheet is about sending data to the AVEVA Insight. And I then choose what format For this purpose, I need to choose the historian, because this allows me then to go into the configuration of that and decide, is it the on-premise historian, the insight using a publisher, or in the likes of Linux, where you've got Linux posting data, there is an alternative way to also push that data. Once I'm happy with my settings there, I just save the sheet. Then I basically use the gateway, sorry guys, just to bring it up, and I create a new cloud connection. And this now uses the built-in publisher within Edge to basically first allows me to choose which of the 3 data centers I want to create my application in, and then it will make a connection to that site and actually start posting my data for me. And it will start sending that data based on the settings that I put in my sheet here, whether it is on every second, or I can save it on change. So I can even have a tag configured to send that data maybe once every 5 minutes if that's what I only require. And that's
so simply put, Tim, you need the tags. So you configure your tags, connect them up to whatever data source there is, Modbus or whatever you've got out in the field, and you tell it what to log, and you simply tell it to go to the cloud, and there you go.
As simple as that, Dion.
Okay, and if we look at things like InTouch, System Platform, SciTech, similar story?
Exactly, Dion. So that's what AVEVA's goal was to build in these publishers into each of the products so that it became native to that product rather than using external applications.
So if you're a user today of any one of our solutions, any one of InTouch, System Platform, whatever, how long does it take you to get from there into the cloud?
Dion, I've done it in as little as 5 minutes. That is linking a tag to a device and up to the cloud. And
can you do you have to, how long does it take to sign? Do you need to sign up, or what? I think there's a trial period, so you don't have to make any investment and you can start testing it.
Exactly. There's AVEVA gives you a 45-day trial. So as part of that process that I was going through, once I'd selected the location that I wanted to use, let's say North Europe, it would then ask me, am I already signed up, or would I like to create an account? If I choose to create an account, it allows me to specify an email address, a password, and then it sends me a link to just activate that email address, and I'm in.
And you immediately there. Okay, great. Sounds good. But now, all right, so that's fine. But not everybody in the world, well, we wish everybody in the world was using Wonderware and SciTech and AVEVA software. But the reality is that people use other stuff. They've got Siemens and all other kinds of things out there. What about these guys?
Thanks, Dion. Yeah, so you're talking about a picture a little bit like this. So there's obviously lots of different packages in the market that we know lots of people use. We know there's a mixture of them on the plant floor. You may not even know exactly what product is working out there if it's been delivered via an OEM. There's a chance you don't know the underlying technology. In that case, I mean, we have worked with customers to work with our standalone publisher. So that publisher comes as standalone as well, because they know that they needed to get that data up there through different people. But there's quite a few configuration steps you'd have to do with that. But because of the brand of AVEVA, there's people like Skynet, who we've partnered with as well, who provided a product called Cogent Data Hub. And what they do is connect down at that bottom level to all of these things that you see, including the competitive SCADAs, your Siemens, your Rockwell, and they have that Insight Publisher built into the product. So that means you can collect the data in real time to it's like one of our OI drivers, and then send that data straight out into the cloud. And again, in terms of security, they actually use a tunneling a tunnel connection from Cogent Data Hub to Cogent Data Hub in that demilitarized zone. So actually, you don't even have to set up things like a proxy or open ports in firewalls and things like that. No inbound open firewall ports. It means that there's no attack surface on that plant network at that bottom layer.
Right. So we can handle really data coming from anywhere we can get into our cloud solution.
Yeah, and I also noticed through your demonstration then, Tim, as well, and this is the same, but there was a little tick box in that configuration for store forward. So that means obviously if we lose that connection to the cloud, the data will be buffered locally until that connection is available, and it'll make sure and send it through to make sure you're not losing information.
Well spotted.
This is one of the fundamentals. I mean, we're talking IoT today, and so one of the fundamentals of IoT is that it is secure. So you're making one outbound connection from your plant area into the cloud, completely secure, and it's lightweight. So we just send the stuff that needs to be sent encrypted into the cloud solution.
Yeah, absolutely. And I've got a few screenshots to show how Cogent Data would be configured. So in this case, we're using an OPC connection to that bottom layer, and we're connecting to an OPC server that it's Schneider, but it's something that has been inherited. It's not something that is native to the solution. So it's just your old random OPC server out there. So we're communicating that way. From the Historian connection, that connection key there, when you click on the little ellipsis on the right hand side, that opens the same Insight Publisher box that you just saw on Tim's demonstration. So you enter the same credentials, it automatically builds that connection key and all the bearer token and everything for you. And then you can see in that bottom screen, it's got all the available points, which are the available points that we're looking at from our OPC server, or OPC, it's connecting to our OPC server. So then you can choose which data you actually want to send up there. And you add it to the system, and then you can see from our connection viewer in our OPC UA server, we have lots of data being sent there, and you can see AVEVA Insight sending that data up to that cloud platform. Just a very simple way of getting that data out there without having to install multiple hops and multiple ways of doing it. You can do it through a central driver.
Right, sounds brilliant. And oh yes, always remember to tell this, so people that might have joined a little bit late, if you want a live demo of this, or a demo for yourself, for your own company, just fill in the chat. I've sent just in the chat box a link to you. Just click on the link and you can request us to come and demo this to you personally.
So if we move that on a little bit, because I suppose we've been doing distributed architectures for a very long time, especially when you look into the likes of infrastructure or renewable energy, the likes of those types of people. They've been needing to communicate to lots of distributed sites. How would they have traditionally done that from a central control system? It would configure a driver centrally, and the key point here is that they'd have to know the IP address of every PLC or every device that's out in the field and do all of that configuration centrally from that driver. They'd all be different because they'd have to be. You've probably got to do that over a VPN or some sort of private network, because they need to be able to communicate across the same network. They need to be able to see each other. And there's lots of considerations when you look at that. So especially when you're looking at things like VPNs, you need to look at things like bandwidth. What overhead is it going to put on the network by introducing X number of extra sites or extra devices? The driver configuration is actually quite complex, and it's that peer-to-peer communication that is making it that little bit more complex, having to manage each individual one. In this scenario, you wouldn't get that store and forwarded data, because we've not got anything locally at each site that is buffering something and sending it up. Yes, we could do it in a slightly different mannerism, but from a driver communicating directly out to these devices, that data would not automatically buffer. You have to decide whether you want read-only or read-write of data, and control can become quite complex, and it can be something that if you have lost that connection, you're not even going to get that right out there anyway. And then as soon as you start to scale, so yes, we're displaying 5 different sites on this picture, but the reality is you're probably actually looking at, you know, the tens or hundreds of sites. You know, it's much larger scale than this. And then how do we manage each individual remote site? And then what happens when somebody does go out to maintain it? How does that work? What happens if somebody changes an IP address? That can be a real headache. So then instead, if we move to the IIoT approach, and in this case, what we're introducing here is an MQTT broker that is sat, more than likely sat in a cloud environment. And the difference here is that from each site, we actually only need to know one IP address. We only need to know the IP address of that broker. So it will then automatically find that broker and send the data centrally to it, and the data that we choose from that edge device. So yes, there's still configuration at the edge, but we don't have to worry about that complex configuration from the driver end at the central control system. We can just publish it from there. So these are classed as then publishers. You can see subscriber underneath, which I'll explain shortly. And then from a central control system point of view, we can then subscribe to that broker. So we can subscribe, and Tim will show us a short demo briefly about all the details of all this. But then that will allow us to pull back the data that we need from each site, and we can build that dynamically. We can build it automatically into that central control system. And the reason you can see publisher and subscriber under there is that if you did want some control down at that local level, we could actually have the central control system published to that broker, and then have the clients at the different sites subscribing to that to look for that change and make that right capability. So the scalability here is obviously much higher. We have things like store on forward capability built into it. And now with the latest MQTT specification, we have you know, secure writes and secure reads and things in there. I think I've covered everything there. I'm going to do.
Yeah, the other things that stand out to me here with when you go into IoT kind of approach, once again, is 2 things to me. Is what you touched on was scalability, because from all your client or from all your remote sites, you're just making one single outbound connection to that broker. So there's no more peer-to-peer communications to configure any of that, and it's extremely lightweight. I think the MQTT protocol is one of the lightest weight protocols out there. So it makes it hugely scalable, much easier to do than try and configure a VPN with all the overheads that you have with that. And it's been designed for this kind of environment. And the other thing, it's widely used. It's a proven technology. It's not something new that you're going to experiment with. MQTT is really established. It's well formed, and with the new Sparkplug B that Tim is going to show, it really takes it to the next level.
So yeah, and Tim's going to describe this slide for us because he's going to take us through a short demo of publishing the data to a broker.
Thanks, Andy. Yeah, I mean, I'll be showing something similar to this. So here we have a wind turbine potentially going to a sort of admin remote IO, you know, bringing some field information to that. Or alternatively, we could be using the RTU and PLC approach. And again, obviously with that tagging that you would normally get in the PLC. From that, we're actually now using an edge, AVEVA edge device to communicate. And we've already seen a little bit about Modbus communications, but obviously there's OPC UA. Importantly, now you've got the AVEVA edge with this payload. You know, it's got the wind turbine, there's a motor and a turbine, and there's some tags under it. We're now going to be talking about publishing that to a broker. And with that, with the new Sparkplug B specification, it's really important to understand that the payload is now, the broker understands the payload. It understands that this device has these tags with information in it. It's very much in context, which is so amazing to see compared to, you know, we've been playing with MQTT for a number of years now. And also with MQTT, you would never know if these values were actually still live and well, you know, are they still current? Because it was a publish mechanism, it would only publish it if it changed. So if you lost communications, you know, how would you know? Sparkplug B specification actually does this. It actually keeps the sort of birth and death certificates. It understands if it's still alive.
I suppose I think that you're talking about the context is very, very important, because once it's published into the MQTT broker, all consumers of the data automatically gets exposed to that context, and they can see that hierarchy of data. So when you want to get data from the system, that hierarchy is in front of you, and you don't have to know the tag name. It will tell you what it's, what's all the remote sites out there, and what data do they have to provide you from all those remote sites.
Exactly, Dion. Otherwise, you know, historically, you would have just had a very big spreadsheet, you know, that you would then dissect and understand, okay, I need to use this tag, this tag. This is all in context within the broker. So can I show you?
Yes, yes. Oh, sorry, and your last step there, sorry, and your last step there was that you actually take it then to your control room area with system platform or something like that.
Sorry. So I'm going to show you.
Yeah, share your screen to them and show them publishing that data to MQTT.
Okay, I'll just do that. There we go. So I'm back on the AVEVA Edge. Now I'm looking at actually the MQTT. I'm going to show you the MQTT setup. So this is, again, as Dion said, a whole host of drivers, you know, within here, and MQTT is one of them. With the MQTT setup and Sparkplug B specifically, is that my configuration within Edge now is just about pointing to that broker. So I'm now just I've just typed in that, you know, I've got IP address of that broker in there. The SP that you might see, I know it might be a bit small. The SP stands for Sparkplug. So this is using the Sparkplug specification, IP address, and then my port number. And as Andy alluded to, yes, this can be both encrypted and secure, or in this case, 1883, the port number is actually unsecure. If I wanted to make this secure, I would just make it 8883. That would be the port number that Edge MQTT would go out on. And because if you are using secure connections, you do need to actually go into the settings, MQTT settings, and then configure the authentication and certificates along with that.
So totally encrypted, secured, encrypted.
Totally secure. And as Andy also mentioned, here is where you set up the store and forward. So one thing that MQTT lends itself to, something similar to DMP3, is over networks with inconsistent bandwidth. You know, it might be up, it might not be up.
Intermittent connections.
Intermittent connections. But with this sheet, I've just sort of provided a latitude and longitude because I'd like to show this later in the demo when we're talking about the subscribing side. I just wanted to pass in some coordinates.
Just one thing you missed there was that header that it talked about, which looked to me like some kind of context. Sorry.
You know how we spoke about with that wind turbine that the broker now understands the hierarchy. So with the Sparkplug B specification, it's important that we give it an edge of network address. It needs to understand the edge of network. This England /north becomes that EON, the edge of network.
So it tells you a regional and then specific in that region where it is kind of. So, but you can use that in any way, I'm assuming in Sparkplug B.
Exactly. I think but the only thing that is important is that the /. The / is part of that syntax, but of course you can use any naming convention. It should be simple and short, I think is one of the recommendations. The next thing I needed to do, Dion, is I have this information. So I have this information. I have an analog and I've got a boolean and I've got a string. I want to bring that to somewhere. I want to take it to my centralized control room. So I have now configured a sheet for this device this is a device that's out in the field, like that wind turbine, let's say, and I've got the temperature, a status, and a string value, and I'm actually almost aliasing it in the MQT sense.
So you're mapping it into that MQTT namespace.
Yes, and this is it. And as you can see now, my header has been updated to now England North RF2011. So later in the demo, we'll come back and see where is this RF2011, you know, how is it seen by the broker? So you want to take it back?
Yeah, thanks very much for that, Tim. Yeah, so that's the first stage. Now, I suppose one of the questions that would come from that naturally would be, well, yes, I can see how easy it is to send the data to a broker. But what happens when I have lots of these devices out in the field? How does that scalability come into play? Because at the end of the day, what you've just shown us, Tim, we're still having to go to each end device and configure every single one. We're still having to send the data out there. Now, what's next for this, I suppose, is something called edge device management, which is something that we can do centrally. And this is something that is, again, it's a web-based, cloud-based solution, and it allows you to develop centrally from a central location and distribute your applications out into the field. So it allows you to configure, make changes, and I've got a short video just showing you exactly how we do that from our web interface. And again, it's something that's very easy to use. So you can see we've got our device list here. I'm going to just create a new device, obviously give it the standard sorts of names. So this is configuring an edge device at the bottom layer, or it's provisioning it, if you like. We are choosing what we'd like to see in this, what type of platform is it running. In this case, it's a Linux device. We're then choosing a specific module to sit on top of it, and in this case, you can see it's the AVEVA Edge system. And here we're choosing the project that you've created centrally. So the project that you've just been creating, Tim, we could zip that up and drop it into this environment. And then from there, we have now created our device. We can see it's not published yet. We want to show how you deploy that. So we do this through something called Flex Credits, AVEVA Flex. And we've now got this detail published for this specific device. So what does that mean? It actually means that we can now pair that end device, that edge device, with our centralized cloud platform. So this is a view of our Linux device at the edge. We are adding that tag from the cloud, the URL into that device, and it's automatically then finding exactly where it needs to go to get its project, to then pull the information down, install it automatically on the plant, and then you can see it's running in a mobile access.
So sorry, Andy, so what you copied there out of the browser was actually the command that you just pasted into your Linux device, and it will then connect itself up into
Absolutely, yeah. So that's what it does. That's what gives the edge device the understanding as to where it needs to go to get everything from the central location. And when you've made that tie together between the two, if you then need to make individual changes to an individual project, you make that change in that central repository in the cloud, and it will automatically pull down that latest project for you. So then if you think we no longer need our AVEVA Edge engineer going to site to configure this system, all we need is an engineer to go and plug in an edge device and then connect it through the command that we've given them through that cloud platform. And then away we go, we can deliver it out there, and then it'll automatically store straight to the centralized MQTT broker, as Tim's just shown us.
Okay, brilliant.
So how does that work? So obviously there's lots of devices that we can install. There's lots of different types of assets at that bottom layer, as we've already talked about, and depending on the bottom layer device, the type of device it is, it might depend on what type of solution you might put in there. But we're talking about, you know, for something that might be very a very high value machine, you can see something like a, like a generator, or some sort of printer machine, or something that certainly in terms of a generator, you'd want to keep the uptime as much as you could do. You may go for something that was more of a fault tolerant type solution, and in like a Stratus. And then as you go down the stack and things become slightly less important, it might just be that it's actually an IP rated industrial computer. And we supply all of these with the right software installed on them, so you can get up and running very, very quickly, and start to utilize it straight away. And then you can see what is it actually doing on the edge device on the right hand side. So that's just a description of the containerization that we're really doing from that cloud platform down to that Linux based operating system.
And this is how we make it easy. So we can give you, depending on what kind of device you want, we can advise you on the best device. We can help you to get these devices going quickly by pre-configuring them for you, and basically get it to you in a state that you can just plug in and go.
Yeah, absolutely.
And I like that thing, you can run Linux. So there's different options in operating systems we have now. You can use Linux, you can use Windows.
Yeah, the actual edge, the cloud management it's Linux only at the moment, but it is coming to Windows as well.
Okay.
And then I suppose the next step would, so we've now got all of our devices are all storing data to our MQTT broker, and we're doing that in perhaps a few different ways. And we've just shown how you might do that through something like edge management, essentially from the cloud platform. So you're scaling it very on a very large geographical basis. And now we want to subscribe to that. So we want to connect to our central control system, our system platform, perhaps, to our broker, so we can pull that data in. And Tim's going to show us again exactly how we do that.
Then I'll share my screen. So this is where we left off. We've just finished configuring the MQTT driver and edge. So this is actually a virtual machine running on my laptop. I'm going to now switch to my Azure machine. So this is a Microsoft Azure machine I've built, where I've actually got system platform along with the new AVEVA MQTT Y server. So let me start here. Like I said, yes, this is the new MQTT Y server for Sparkplug B specification. Previous MQTT driver used to reside under the gateway, so just FYI. Setting this up is just about pointing it to that broker. So this is actually the URL for that. Same port number. Once I've done that, I can just validate the address just to check that I have a connection to that host, and I do. And then this is where the exciting stuff comes in.
Just before you get there, sorry, I just want to see. So the same security encryption stuff is all in there as well. I just saw that in there.
Sorry, yes, yes, that's right. I mean, I could have enabled TLS that would change the port automatically to 888.3, and then I could also still protect this with username and password and set up my certificates. Absolutely.
Sorry for interruption.
That's fine. We'll do a second drum roll. So this is the
Sorry, I stole the moment there.
Well, it's actually fine. I love looking at the screen. So this is all I'm doing is zooming in and out, because clearly you could quite easily have quite a mind map, as Andy sort of spoke about.
There could be thousands and thousands of devices in the field, and it will browse all of them.
Look what's important, Dion and Andy. There's my edge of network, England North. This is what it is. There's my longitude and latitude. And you think to yourself, now, why did we put a longitude and latitude there? Well, I can switch the browser to actually geolocation. And this is the geolocation of where those coordinates are pointing to. So imagine you did have hundreds of devices. You would see them dotted along the coast, or the east coast of England maybe, and be able to click on each of those dots. And straight away, it's telling you, the tags that are coming from that device. Obviously, I just switch back to here, north, RF211, and there's my tags. As I click on each of those tags, it gives me the full tag reference. Sparkplug B version 1, England North is my edge of network, RF2011 is my device, and then this is my oil temperature. So this is within the broker. And it's great to use. It really is. going one step further, if I may, is to now actually, inside system platform, I had obviously just created a very, very basic Galaxy with a platform and an engine with the SweetLink connection to my MQTT driver. But I've created a remote device with just the oil temperature, running, and label.
So you'll set up templates for your kind of devices you've got out there. All right.
That's right. And then, of course, I've now made an instance of that, RF2011, and I'm actually seeing the values update here. What I will show you is I've just got Object Viewer, which is more of just like a runtime window. I've got the oil temperature, running, and label. And if I switch through to my virtual machine, I just give this, I will rather type in Andy here. I will stop the pump. If I now go back to my Azure machine, I have got Andy, false, 2852, and a round of applause.
Well done, Tim. Really proud of you there.
That is really just how amazing MQTT is. You know,
the speed at which you do this stuff is quite. You know, when I started playing with MQTT a number of years back, and I must say it's just improved in leaps and bounds, and the speed at which you can now build a system is just incredible.
Yeah. And
the speed of the interaction was impressive as well, because that is actually going to a cloud-based broker, isn't it?
The speed is amazing. And even now with the Sparkplug B, I'm going to do the unthinkable and actually shut down my edge and go back. And what do you notice? Quality immediately is bad. All three of those tags. It knows that no longer exists. So it has that, carries that full payload. Even on my, even in my browser, it actually says it's been down. It actually now colors the tag in gray and says it's down. So my broker, or should I say the MQTT browser knows, the AVEVA browser knows that my device is now offline. It's just amazing.
Brilliant.
Yeah, really impressive. Okay, thanks, Tim. So I guess the next step, or we've now got our data centrally. We're doing all sorts of good stuff with it. We still might want to send our data to Insight. So yes, we could do that directly from our AVEVA Edge products at the bottom, but you can see the benefits of the reason why you might go down that MQTT approach instead. So the likelihood is when you're doing that and you're subscribing to it, and you can now start to do things like write commands from that central control system, because we have full read-write capabilities, as you just saw. You might then store that data locally in that centralized repository, and in a bigger story, and we may then publish that data to Insight from there. And then we're only publishing the key data that we actually need and the people need at that from a management level. But we can actually start to do more with that data once it's up there. So we don't need that heavy overhead of having something like an artificial intelligence solution at the edge. When we're getting those values back centrally, we can send that data to the AVEVA Insight cloud, and we can have that handle all that information for us, and provide us with the anomaly detection and the machine learning type solutions that we've started to talk about more recently. And then if we look at future proofing, because we know that, yes, we talked about MQTT today, but there are lots of other ones out there on the market, and there's, it's one of those battles, isn't it? There isn't a single protocol that is dealing with the market. We have the likes of people like LoRaWAN, where you install local gateways, and you're managing a lot more of that communication locally before it goes up to a wider network. You've got the Sigfox network, which is something that works more similar to what you'd see on mobile. So it has an area of coverage, and the coverage wasn't the best a few years ago. It's now certainly getting a lot better, but you'll certainly have a better Sigfox coverage in the bigger cities over out in the sticks, because it has to physically communicate to a mast that's out there in the field. and that you're not managing, which is the key point to that. So we understand that all those things exist. So we've been looking at another partner in Rico who will integrate all of these solutions into one. And again, because they are working very closely with AVEVA, they have things like the Insight Publisher again built into it. So from all of these systems, or back to system platform, you could get that translation of all the different types of IoT data and all the IoT protocols and the different weird and wonderful things that are being used, translate it in Rico and then send it out to an Insight platform. And that's when we can start to the things that I was talking about just before, things like your artificial intelligence, your machine learning. You may go out to enterprise systems, things like maintenance, being able to set up automatic work orders in maintenance systems because we know that there's something out in the field that needs repairing. We can do that automatically through this route.
And I suppose the thing that stands out for me here, Andy, is that when you go into IoT, you're talking an ecosystem, because you can't be everything to everybody. And I think this is what we as Solutions PT really do well, is that we bring this ecosystem together. So we look at what is the best of breed, what's the best solutions for our customers out there. Like you're showing over there, you know, for you, Sigfox might be better. For somebody else, LoRaWAN might be better. Some people have got different kind of ERP systems to integrate you, and we bring all the tools together to build a solution for you. The other example there is we put system platform there into the cloud, because it's supported on cloud. So we can help you with a cloud service, and, you know, instead of running your system platform on premise, you could run it in the cloud. So lots of options, and really we specialize in how to navigate all those options, bring and help you get to the best architecture.
Yeah, thank you, Dion.
Yeah, so I suppose we've come nearly to the end of our presentation today, or of our webinar. And again, I want to come back to those key takeaways, and I hope we made that clear today, is that IoT really can deliver on that promise. You can use it to make a positive change. You can do it very quickly with minimal investment. And as I said, we're here to help you on that journey. So to help you on that journey, if you click on the next one, Andy, I think. If you do another click, yeah, is I've popped again into our chat line. If you want a demonstration, just click on that. It'll take you to a page where you can just register for a demonstration. It'll show you how all of this works and help you get started. So let's get to our questions. Let's see the questions. Okay.
The first one, he said it was before the demonstration, Dion. So
the sign up per project or based on my email itself?
No, I think it's the Cogent Data one, isn't it?
Yeah, it's Cogent, yeah.
So I mean, it's probably still worth pointing out that Cogent Data Hub is owned by a company called Skynet. They've been working with AVEVA to make sure that they can develop things like you know, these Insight plugins, but they are still an agnostic driver or communicator, because they have to be to get out there. But the benefit is that they're partnering with AVEVA to do the special things that we've been able to show you today. There's another question around the sign up. This is the sign up of AVEVA Insight. So Tim mentioned earlier about the 45-day free trial, and whether it's per project or based on the email itself or their email. So yeah, it's based on email. So the username for that solution is your email address. So that's how you get into the system. And it will provision everything for you in the back end. You simply fill out a form and it does it all for you. So you could use it for one project, or you could use it for 5 projects in that 45 days, because you can send data from lots of different data sources all the way up to that central cloud platform.
And then I think the last question we've got is, would it be fair to say that for a distributed DAQ requirement, OPC UA is now much less useful, and MQTT will supersede OPC? So that's an interesting question, and there's much speculation, I suppose, out there about, you know, which protocol will win. I can tell you my personal opinion on this is that I think time will tell, and our strategy is to support as many protocols as we possibly can, but select to use them in the appropriate way. Like if you look at OPC UA, it is very good. The standard OPC UA protocol is very good on a peer-to-peer communication. So locally there, as Tim showed, inside of on the edge, OPC UA might be very appropriate. But when you want to go over the cloud, MQTT would by far be the better protocol, most probably.
So you make a mix of the two.
Yeah, so it could be a mix of different protocols. And we will look at every situation and weigh up the pros and cons of using the protocol in that situation. I think that's about it. I don't see any other more questions in here. Is that right? Okay. All right. So thank you very much, guys. I really, really enjoyed this session today. I think I've learned a couple of new things, and I hope the rest of you out there has learned a lot. So thanks, Tim. Brilliant demonstrations.
Thanks, both of you. Thanks, Andy. Thanks, Dion.
Thanks for all the hard work on that. And Andy, brilliant PowerPoint. I think you really explained the concepts in a nice, simple, and easy to understand way.
Thanks, guys. Yeah, I really enjoyed it as well. It's a very interesting topic.
Yeah, I think so as well. So all of you, thank you for joining us today. And we hope you have a wonderful rest of the week. Goodbye.
Thank you. Bye, everyone.